Welcome to Physics NECO 2026. Make sure you watch to the end to obtain maximum points tomorrow in your exams. Physics. Follow every instruction in detailed manner, and ensure you have a neat and decent graph tomorrow. All the process will be communicated here. So let's go straight to the questions without further ado. Let's go to question number 1. Question number 1. This is no joke. Make sure you follow up to the end. Say you are provided with a rotor stand, spiral spring, mass hanger, and set of masses and a stopwatch. Using figure 1.1 as a guide, carry out the following instruction. So these are the instructions. Most importantly, you should take notes of the data given to us. The mass hanger is of 40 grams. That is the mass hanger, which is this man here. It's 40 grams. Okay, so what happened next? You are going to oscillate these 40 grams in 20 oscillation, which is vertical oscillation. Will be going up, down and up for 20 oscillations. If you go down and up, that's one oscillation. Go down and up, that's another oscillation. These experiments have been conducted live and direct, but I won't show you the process. But what I will show you is the table of values for this process, and it's 100% accurate, no jokes. So let's go straight to the question. So if the mass hanger is 40 and you are adding 20 gram mass, so the total mass you are now having is 60 grams. So from 40 I move to 60. Then you oscillate again for 20 oscillation. Let's go straight to solution to question number 1. So to answer question 1, question 1A, Roman figure 9. So you should tabulate your reading. That's what the question says. 1A, Roman figure 9. Look at it here. We are asked to tabulate the readings. So asked to tabulate the readings of these values. 1A, Roman figure, tabulate the readings. So if I want to tabulate these readings, let me do it here. So you should be able to do this with your ruler and the biro tomorrow. So I will write number of oscillation, number of oscillation, number of oscillation, which is n. The value is 20. So with that known, I can now draw the table of values. So make sure this table you are seeing here is not manipulated. The experiment was 100% conducted. These are not manipulated tables like the one you see online. It's not manipulated, it's 100% conducted. So here we have the serial number, which is number of time I'm performing the experiment. It's done 5 times, 1, 2, 3, 4 and 5. Then I will have the masses now. You must put the units in grams. So experimental values are already written to minimum of at least 2 decimals. So the first mass is 40 grams. I'll have 40.00, followed by, if I add another 20 grams, it becomes 60. Another 20 grams become 80. Another 20 grams is 100. Another 20 grams is 120. So I will now determine the time of oscillation, which is t in seconds. So for the 40 gram, the time of oscillation is 5.70. Then for 60 gram, I'm having 7.24. For the 80 grams, 7.92. For the 100 gram, I'm having 9.03. And for the 120 gram, I'm having 9.76. So from here I will determine the period. Period is time taken over the oscillation, also in seconds. And the oscillation is 20. So people will just write small t over 20 for depends on the individual. So if I use 5.7 to divide 20, I'm going to have 0.286. So if you look at what you have here, 0.285, I mean, I'm writing to 3 decimal. That means every number on this column must be to 3 decimal. So if you want to approximate to 2 decimal, you can do that, but that is gross approximations. So make sure you follow the decimals. Then if I go to the next digit, I'm having 0.362. The next one is 0.396. The next is 0.452, and finally 0.488. So we now have t square, which is second square. So make sure you square each of these periods. There is difference between square and root. You are squaring, you are not finding the square root. So if you square 0.285, we are going to have 0.081. The next one will give us 0.131. The next 0.157. The next 0.204, and the next is 0.238. So this is the table of value according to the question. Like I said, no joke, 100% accurate. So the next question, you have done that. You are asked to next question and say you should plot a graph of m on the vertical and t square on the horizontal, starting both axes from the origin 0, 0. So this is the, so what you do now, you go to the portion of the graph in your booklet to plot the graph. So I will illustrate it how to do so. So you start by taking a scale. So I'm going to take a scale. So at the bottom of the table, I can just write the scale there. At the bottom of the table, we can put the scale. So let's see. Based on the values, we determine what you are taking as your scale. So for the m, I'm having difference is 20 grams. So I can say scale. The m is on the vertical. The mass is on the vertical axis. I will now write scale on vertical axis. This thing has core. You must state it. Scale of vertical axis, which is there, is the mass in grams. We are using 2 centimeter to 20 grams. So for every 2 centimeter, I'm putting 20 grams. So let's also find the scale on the horizontal axis. I will say scale on horizontal axis, which on the horizontal axis, period square. I will put the unit also. We're also having 2 cm. Now if you look at the values we have in the horizontal axis, is we have 0.081. So what we do for easy calibration, I will convert these numbers to standard form. I will convert them to standard form. But although you can still plot like that, but I prefer it this way. I can write this one as t square times 10 raised to the power minus 2 second square. That means I'm converting each of them to standard form. So here it becomes 8.1. Here it becomes just 8.10. Let me just use that. Times 10 minus 2. So every number here is divided by or multiplied by 10 minus 2. Here will give me 13.10. Here will give me 15.70. Here will give me 20.40. Here is now 23.80. So it's better this way. So I can easily take this key. So the least number is 8 and the highest number is 23. So I can take, I may choose to take now 2 cm to represent. If you are going to use 2 units, the graph will not be enough to accommodate all the figures. So I will switch to 5. So I will say 2 cm to represent 2 cm to 5 times 10 minus 2 second square units. So this is now my scale I'm using for figure 1. You will give testimony tomorrow, follow to the end. So what we do now, you take your ruler and pencil, you are going to draw a perfect vertical line and a perfect horizontal line. So I will label here M, I'll put the unit in grams. Here is now t square times 10 minus 2 second square. So I will label here now as 0, 0. So it must start from the origin. So for every 2 cm we put 20 grams. Here becomes 20. Here is 40, 60, 80, 100. Here is now 120. So you can label above that, but let's just, for the purpose of this class, let's just stop it at 120. So 2 cm to 5, so every 2 cm here becomes 5, 10, 15, 20, 25, 30, 35. Like I said, you can also label above this. So I've taught students before how to plot graph. I will put the link on the comment section so I go and know how you can count each of the smaller boxes you have on the graph, so you don't make mistake tomorrow. So there's a calculation you must make to ensure you count correctly, because each step you count wrongly or you asterisk wrongly, it comes with deductions. So when you plot the graph, you are going to have something of this nature. So 8.1 should be around somewhere here. If you count it correctly, then the value is you asterisk 40. Then the next one is after 8.1 we move to 13.1. 13.1 should go beyond 10, and the value is 60. I'm going to have, this is just rough work. Like I said, I will put this scale, the link to that video on the comment section. Then we have 15.7, very close to immediately after 15, 2 boxes after 15. Like I said 2 boxes. Watch the video and know why it is 2 boxes. We have 80, so that is how you will continue in that pattern. Then we have 20.04, 20.4. I mean, we have you cannot count 0.4, so you take it as 20. You have 100, so it continues. Then we have 23.8, very close to 25. You can count it. You have 120. So you use your ruler. It must not come like this. Sometimes all the points can go in, sometimes they will not. You rule a thick straight line like this. So this is how the graph will look like tomorrow. This is how the graph will look like. Then next, you are asked to determine which is xiv. Determine the slope x of the graph. So the slope, now what you do is this. You take your ruler and pencil, you draw a perfect right angle triangle on this line. You can use any point you want. Draw a perfect right angle triangle on this line. So you can put it like this. So on the vertical axis is changing m, on the horizontal axis is changing t square. Don't go and write your slope and change the y by changing x. We are not plotting a graph of y against x. Please take note. So how do you determine the slope now? So my slope, which is xi now, if I'm not mistaken, slope is question xi, yes. So my slope now, which is xi, I will write slope, open bracket, x is equals to change the m over change the t square, which is m2 minus m1 over t squared 2 minus t squared 1. This is what we have. So how do I get my m2 and m1? So from this point, you can still use your ruler and a pencil to make it a trace. So if you trace, here we're having here as 100, we trace here we're having as 40, trace here down, and trace here down. Although it's not compulsory you must do this, but for clarity, you can just do so. So we're having, for the m, I'm having 100 minus 40 over, for the t squared 2, we're having 20 minus 8.1. So if you simplify, here will give me 60 over, then if I subtract these two, 20 from 8.1, that will give you 11.9. Let's say approximately 12. So if you divide now, what are we going to have as our slope? Slope x now will be what? So 60 divided by that, we are going to have don't forget, here is multiplied by 10 minus 2. Don't forget that, because it's written as 10 minus 2. So don't forget that. Even me, I'm about forgetting it. So make sure you pay attention to details. So I'm going to have 5 times 10 minus 2 grams for the up / per second square. You must put the units of the slope. We are having 5 times 10 minus 2 grams per second square. That is the slope. So let's go to the next question. Next question says evaluate. Next question says evaluate k equals to 4 pi square x. So we've gotten x, your x is the slope. All you need to do is to write k is equals to 4 times 22 over 7, which is value of pi, all squared, times 5 times 10 minus 2. So if you simplify this, what are you going to have? I'm having 4 times pi square is approximately 10. The value of pi square, you can try that in your calculator, times 10 minus 2. Pi square is approximately 10. So if you multiply this, 4 times 10 times 5 times 10 raised to the power minus 2, 10 raised minus 2, we are going to have so we're going to have 2 grams per second square as the value of k, because the unit of this is also grams per second square. The whole of this is constant, so we are still maintaining grams per second square. Now Roman figure 11, so you should state the precautions. So you should state the precautions to ensure accurate results. One, you must make sure you have I ensure vertical oscillation and not side oscillation. So this is a vertical oscillation. Then 2, you can write and ensure, this is the most common one for all students, and avoid error due to parallax. Just stop there. Where do you avoid the error? You state it when taking my readings from the stopwatch. You must state that device where you avoid that error from the stopwatch. So let me make it 3. You can write any 2. Then number 3, I can also say I ensure error. So I can say I ensure zero correction. Zero correction of the stopwatch. Sometimes the stopwatch will not be at 0. You may ensure it's at 0 before you start conducting the experiment. So you can use any two tomorrow as your precaution. So let's go to question. Let's go to question 1B. It says state three characteristics of. State two characteristics of an oscillatory motion. One, one, it is to and fro motion. That is one. Two, I can say it varies with oscillation. It varies with oscillation. And 3 is also varies with it varies with time and period of frequency. You can use anyone. Vary with time, period of frequency. Then you say you should B now. Remember to go numeral 2. B numeral 2. You say we should give you example of bodies performing oscillatory motion, like we said. B remember to go 1. We have numeral 2. Example of body performing oscillation. We have the diving board, the one they use in indoors Olympics. 2, we have the vibratory string. Then 3, we have the pendulum bob. We have the pendulum bob. Then number 4, we have a loaded test tube in water. Yeah, so you can use any two tomorrow to explain that. Then let's go to question 1B Roman figure 2, which is the last question for question 1. 1B Roman figure 2. So what we have here is under Hooke's law. Say a body of mass 5 kilograms suspended vertically on a spiral spring. So they didn't ask us to draw the diagram, but if you want to tell the examiner you know what you are doing, you can just sketch the diagram. So a spring must have a spring constant K. The S original length, and we produce an extension when a load of force is applied. We know that force is something as the weight or the load. The value is mg. So if I multiply now, I'm having 0.5 times 10. The force now will give us 5 Newton. So we know that F from Hooke's law is Ke. So my K now, which is the force constant, is F over E, which is 5 divided by 0.2, which is the extension here. Which value is this? We are going to have 25 Newton per meter. That is now the value of the force constant. So with that, we've answered the whole of question 1 correctly. So I would recommend you answer any of them. Question 1 most importantly, and question 1 is very easy and easy to go by. And question 2 or 3. Question 2 it involve traces. Let's go to question 2. Question 2 is a rectangular glass prism. That's question 2. So the standard glass prism they are using, most schools are using right now, is the one that look like this. This is the standard one a lot of schools are using. So you can actually perform this experiment without actually conducting the experiment itself, although you have to conduct it because you need the tracing. You have to attach the traces to your booklet. So your normal, let me just give you some tips. The normal is always 1/4 of AB, the length of AB. So the length of AB, I've done the measurements, is 10 cm, and the width, which is AC, or something as BD, the value is 6.4 cm. All these measurements have been done today, so I'm just stating the facts. So 10 cm divided by 4 is going to give you 10 divided by 4 is going to give you 2.5 cm. So you have to measure I have to measure 2.5 from here. That's why you draw your normal. You will continue like that throughout the experiment. So let me show you some tricks on how you can obtain these values without actually conducting and make life easy for you. So it is my glass block now. Let's take this as our glass block. So I've shown you how to get your normal. Your normal is now here now. When you do the 2.5, you place your protractor here to mark this point to be on 90, to mark your incident ray, which is 20. Okay, so you use your glass block to trace this outline. We know that from sinusoidal refraction, refractive index is sin I over sin R, and the value of a glass block is always 1.5. So my sin R will be what? Will be sin I over 1.5. So R will give us the sine inverse of the incident angle we have is 20, which is sin 20 divided by 1.5. If you do that, I'm going to have, so let me try it out and see. So if you do that, your reflected angle will be 13.2 degrees. So all you need to do is invert your protractor this way. Here is also 90, and count 30.2 from here, and you mark your reflected ray. Then we are told from the question that from O to Q is Y. So if you do that, you have to do just to measure this point. That here will give you 1.5. Then here is the emergence ray. Your emergence ray is I is equal to the incident ray. So you take it as 20, you draw. So this is the easiest way to manipulate it. So how do you get the L? Remember we said from here to here, which is the width of the prism, is 6.4. And this angle we calculated already is 13.2. So here where you have the right angle triangle, or you can use Pythagoras theorem here to find this length, which is 6.4 square plus 1.5 square. It will give you this value here. Or you to conduct the experiment, but this is more accurate than the experiment. This is more accurate than the experiment. When you do so, these are the value we came up with. Like I told you, it's 100% accurate. Let's see. Let's now question 2. So pay attention to these details for you to have a brilliant exams tomorrow. So these are the values we came up with. That will be question 2A, Roman figure 8. 1, 2, 3. So this is what we have. We have our serial number, which number of times the experiment was conducted. The serial number is 5 times, always 5. But some cases you can have it as 6. So here's 1, 2, 3, 4. Then we also have, let me make it clearly. Extend the table a little bit. Here is now 4 and 5. Then we have the incident angle in degrees. Remember to place the angle here becomes 20.00 is the first angle, followed by 30, followed by 40, followed by 50, and lastly followed by 60. Then from there now you now have your OQ is equals to Y in cm. It's in centimeter. Make sure you state the units. So the first value we have there is 1.50. Second one is 2.26. The third is 3.00. The fourth 3.80, and the fifth 4.50. These values are 100% accurate. Then we also have our L in centimeter also, which is from N to Q. First value we got is 6.60, followed by 6.80, followed by 7.10, followed by 7.40, followed by 7.80. Then we have phi as 90 minus the incident, also integrates 90 minus, so 90 minus 20, that should give, here we've done 70.00, that will give me 60.00, that will give me 50.00, here is now 40, and here is 30.00. Then lastly, so we should find Z. The Z is equals to L cos phi. So you press conservative, multiply by the length 6.60. That will give us 2.26. We do the same for the other. We're going to have 3.40. The next 4.56. The next 5.67, and the next 6.75. So this is the table of value. Like I said, 100% accurate. If you go with this value, you are going to have your refractive index, which is 1 over the reciprocal of the slope, which is the reciprocal of the slope. You give 3 over 2, which is 1.5, which is the refractive index of a glass block. So let's go to the next question. So question says you should tabulate your readings. Like I do, that is the table. Then you should plot a graph of Y on the vertical and Z on the horizontal. So let's also go. But before then, you need to know the scale you want to use. You must state the scale. It has its own mark. So we are having a graph of Y. So you can write it, a graph of Y versus, I have a graph of Y versus Z. Then I will now state my scale by writing scale on vertical axis. And which of the vertical axis is my Y? Upper bracket Y is centimeter. What are we having? Always use 2 cm to how many units? So let's check the highest value of Y and the lowest value of Y. The highest value of Y is 4.5. The lowest value of Y is 1.5. So I can use 2 cm to 0.5 units to 0.05 cm for the vertical. I also consider scale on horizontal axis. So horizontal axis. So the horizontal axis is Z, also in centimeter. We're also having 2 cm to, let's consider the values we have in Z, the highest and the lowest. The highest is 6.75, the lowest is 2.26. So I can use 2 cm to 1 unit, 1 cm for the Z. So you go to your graph after this and use your ruler, draw a very descent, a vertical line and a descent. So I will put my Y and the unit is cm. I will put my Z and the unit is cm. So for every 2 cm, I'll put 1. Here's now 1, 2, 3, 4, 5, 6, and 7. Yeah, for every 2 cm put 0.5 and 1.0. Here becomes 1.5, 2.0, 2.5, 3.0, 3.5, 4.0, then down to 4.5. So you start plotting your values, your table down. Start plotting the tables of values. So let's see tables of values for that particular question. So I've written the table before, I can't find it. So based on the table, like I said, if you plot your graph, you're going to, all the points will go in and it will come from the origin. I hope you, I will just rewrite the table for the purpose of this class. I'll write the table so that you can use it to plot. So I'm going to have a perfect straight line from the origin if you use these values to plot. So let me rewrite the table and see. Let me rewrite the table. So you can copy it down, memorize the values. We have serial number. Here's my serial number. Is 1, 2, 3, 4, and 5. Here we have the incidence in degrees. 20.00. We have 30.00, 40.00, 50.00, 60.00. Then here we have our Y, which is in cm. The value of O to Q from your tracing. You have 1.50, 2.26. You have 3.00. You have 3.80, and we have 4.50. Then we have our L is cm, which value of NQ. So the first value we have there is 6.60, followed by 6.80, followed by 7.10, followed by 7.40, followed by 7.80. Then we now have our phi is 90 minus the incident in degree also. So 90 minus 20, that will give us 70. 90 minus 30, that will give us 60. That will give us 50. That will give us 40. And that will give us 30. Then we also have Z as L cos phi, which is cos 70 times 6.6. That will give us 2.26. Then the next one will give us 3.40. The next 4.56. The next 5.67, and the next 6.75. So this is the table down. So take notes. Now we plotted this. You now ask to determine the slope now. Ask to determine the slope. So based on the points you plotted, let me just, these are the points. These are the points plotted. Like I said, all the points. If you watch the video, I'm going to put on the comment section as link how to plot a graph. You should be able to determine your slope correctly. So here becomes a change in y over change in z. You can trace down, like I said, the first question. You can trace down to know the value you have here. You can trace down. So you should be able to count these values. Watch that video, you find it very helpful. So I should be able to determine the slope from here. So my slope now, in this case, slope x will be change in y over change in z, which is y2 minus y1 over z2 minus z1. So if you evaluate based on this slope, like I said earlier, everything has been done prior to now. So what you are seeing are perfect figures. So the slope x will give you 2.00 cm, over 3.00 cm. So cm go with cm, the slope is 2 over 3 or 0.667, no units. Then the next question asks us to evaluate, look at it here, say evaluate k equals to 1 over x. Our x is 2 over 3, so my k become 1 over 2 over 3. Find y, which is 1 divided by 2 over 3, which is 1 times 3 over 2. So the k is now 3 over 2, which is something as 1.5. That's not the value of the k. So next question, numeral 7, says precautions. So we have a x, v, I. So what are the precautions? Precautions. Let me write what is common, known to most people. Number 1, avoid error due to parallax. When taking, don't just stop there. Avoid error due to parallax. Doesn't make sense. On what? When taking my readings from the ruler. So you must state clearly which device you are using or equipment. Number 2, I ensure, because there are many, you can just control. Let me just write a few of them. You can say you ensure, or I ensure neat tracing. I ensure neat tracing of the outlines and the points of the optical pins Okay, then this is number 2. Let's make it 3 because of time. Number 3, you say I ensure the pins are placed, the pins are reasonably placed. I ensure the pins are reasonably spaced, which is true. You must really space your pins. So that is that. Then next, this is what I was saying. You say you should attach your traces to your booklet, so you should be able to do that tomorrow. Then this question, it says state 2 types of reflection. We have 1, regular reflection, and 2, we have diffused reflection. That is that. Then numeral 2, this is numeral 1. Numeral 2 says, why light ray changes direction. It's simple, due to change in speed, or density, as it travels from air to glass. That's the reason it's traveling from air to glass. Then the next question says the calculation. It says calculate the speed of light in water if the speed of light in air is this and the refractive index of water is this. So refractive index, as you know, is C over V, with speed of light in air over speed of light in water. So my V will be what? Which is speed of light in air over refractive index. My V simply is 3.0 times 10 to the power 8 over 1.33. So if I divide from my end, what am I having? 3 exponential 8 divided 1.33, that will give us 2.25 times 10 to the power 8 meter per second. So that is the solution to question 2. You can write this tomorrow. You are sure of having the perfect score in your practicals. And make sure you plot a very decent graph. Otherwise, no matter what you write, you cannot pass these exams without a decent and reasonable graph. That question 3, which is page 12. They give us the circuit diagram. The EMF is connected in parallel to the voltmeter. We have the key, you have the ammeter, and you have your resistance bars. The resistance bars, so we are dealing with 1 ohms, 2 ohms, 3 ohms, 4 ohms, and eventually 5 ohms. Say you should, in this case, read and record the value of V and the corresponding values of I. So you don't have any V minus 1 and the I minus 1 is not required on this graph, on this table. So like I said, this experiment, let me repeat it again, has been conducted professionally. And you can follow through with it. You are sure of obtaining a perfect values tomorrow. So what I will do now, let's draw the table for question 3, VII. So we're having a VII. So I'll recommend about the EMF. We are using to say 3.00 volts. So we're having the serial number. This is my serial number. We have 1 to 5, 1, 2, 3, 4, and 5. We have the resistance in ohms. We must state all these units: 1.00, 2.00, 3.00, 4.00, and 5.00. So I have my I in ampere, which is A. So if you conduct the experiment, I'll explain how they conducted. These are perfect numbers. 0.9, we have 0.8, 0.6, we have 0.5, and 0.4. We have the voltmeter, which is measured in volts. Put your units. Here will give us 1.90. Here is 2.10. Here is 2.50. And here is 2.70. Here is 2.90. So with this is perfect. Like I said, I can't stress this enough. These are perfect values for the questions. Then let's see what the next question says. So from there I say plot the graph of V on the vertical and I on the horizontal. So V is on the vertical. So before then we need to take our scale. Let's take our scale for V and for I. So I will write scale on vertical axis. How is there? V in volts. So we have it. I already recommend 2 cm to watts. The highest is 1.9, the lowest is 1.9, and the highest is 2.9. So we have between 1 and 2.9, which is 2 and 3. So I can use 2 cm to let me think about it very well. I can use the same thing tomorrow. No need to change anything. So I can use on the vertical now 2 cm to, let's say, 0.5 volts. So let's also take scale on the horizontal. Scale on horizontal. You must state all these things. They have their own max. Horizontal axis, which is I in ampere. So we're having 2 cm, like I said, recommended. Let's find the highest and the lowest value. We have 0.4 and 0.9. So I can say 2 cm to 0.20 ampere. So that's what we are using, 2 cm to 0.20 amperes. So we're going to draw a perfect vertical line and a perfect horizontal line. So you write I here in ampere, you write V here in volts. So you calibrate according to the scale you've taken. 0, 0, here's 0.5, here's 1.0, 1.5, 2.0, 2.5, 3.0, 3.5, just like that, depending on what you have. So here we have 0.2, 0.4, 0.6, 0.8, 1.0, 1.2. So when you plot, like I said, that when I watch down my video, you know how to count all these values. When you plot, because of time, go and watch that video. You're going to have a negative graph in this manner. You're going to have a negative graph in this manner. That is the nature of the graph. So that's what you're going to have. That's the nature. Now I said determine the slope. Like I said, this is negative graph. You draw a perfect vertical and a perfect horizontal. So here becomes a change in V. Here is now change in I. So your slope now, which is X, will be change in V over change in I. So that we're having V2 minus V1. Here will be I1 minus I2, which is the negative value we are talking about. So when you pick any two suitable values in that point, your slope should be able to give you the slope now should be able to give you minus 1.75 to minus 2.0 ohms. Sorry, not ohms, even though we know it's ohms, but you put it according to the units. Here is volts, here is volts and ampere. So if I'm doing it, it'll give me volts per ampere. I need V over I is ohms, but accept they ask you what does the slope represent, then you can tell them. From now you write volts per ampere. So that is that. Then we're asked to determine the intercept of the vertical. As you can see, the line of best fit now meets the vertical axis at this point. So if you plot your graph correctly, it will not stop at exactly 3.5, it will stop at, so I would say the intercept is 3.60 volts. That's what you're going to have. You can have 3.5, it depends on how you position your ruler. So that would be our intercept. Then next, so you should evaluate K equals to E. K equals to E over C. What's the E? Is total cell we use, which is 3, and the intercept is 3.60. So your K will give us what? We have our 0.833. This is volt, so they have no units. I just have 0.833. So that is question XI. Then precautions. So let's see which precaution we can use here. Let's take the two precautions. I'm tired already. Let me just give you two. I ensure tight connection of the circuit. That is one of the circuits. Then two, I ensure the key was open. The key was opened. I ensure the key was open when no reading was taken. Open when no reading was taken. And the most popular one, I ensure I avoid error due to parallax when taking my reading from the voltmeter and the hour meter. You have to specify the device you avoid that error. Then you also ensure zero error on the ammeter and the voltmeter. Those are also precautions. So differentiate between resistors and the capacitor. You can use that definition. You can just use their units. Resistor is in ohms, while capacitor, or you can define both of them as a different. Capacitor is in farad. Capacitor is in farad. As simple as that. Then we have the question number 2. Number 2, we said two identical cells, each of these internal resistors are connected in parallel. So if they are connected in parallel, this is what we have. This is the EMF. This is another. So this is E arrow, E arrow. That's what we have. Parallel to each other. So derive an expression for the current that we pass through a resistor of resistance this. So it's connected to a resistor. So we have, this is the resistor now. Let's take it as the resistor. We have institution. Although they didn't ask us to draw, but it's good you draw for a better illustration. So the current will flow here, which is I. Continue flowing. I continue flowing in this manner. Come here back to the source. So for parallel arrangement, your E1, which is E2, the value is just E. It's constant. The EMF is constant. But what about the internal resistor? So I'm having 1 over arrow, 1 over arrow 1 plus 1 over arrow 2. Since I arrange the parallel, so I'm having 1 over arrow plus 1 over arrow. So my SM is arrow. That will give me 1 plus 1, which is 2 over arrow. So the total internal resistance now give us what? Arrow over 2 in ohms. So with that, I can calculate or impute the current now. I know that I is E over big arrow plus small arrow. So this one implies that I equals to E over big arrow. Yes, now arrow over 2. If I take SCM and simplify here, my I will give me 2E. Oh yes, over 1. Take SM and invert. You're giving 2 arrow plus small arrow in what? In ampere. So this is the expression for the solution. So let's check. I don't think there's any other question, but let me just check. There's none. So you can reach us in one of these sources for personal classes and lectures. We treat a large range of subjects: physics, chemistry, computer science, data processing, mathematics, further maths, technical drawing, among other areas. We're also into jam training and also help you process your forms. So you can reach us when you need us on this contact. So see you and be very well tomorrow. So make sure you like, subscribe and like this video if you have not done so.